In this video, we're going to look at polarization of electromagnetic waves, and this is covered in chapter 34.8 of the textbook. Okay, so what is polarization? So you can have a wave that's linearly polarized, and what that means is that the wave is oscillating or waving in only one plane or direction. So for example, in the picture here, so imagine we have some electromagnetic wave. So again, this is just the E field part. We're not showing the B field part. That would be in and out of the screen. But so if the electric field part, right, so is just oscillating in the Y direction, so positive Y to negative Y. And so again, this is what you would see from the end. So now here the wave is coming right at you, and you see it waving up and down in the Y direction. So we'd say this wave is linearly polarized because it only oscillates in one plane or one direction. Now, of course, more often than not, depending on how the waves are created, a lot of electromagnetic waves are unpolarized. So unpolarized means, again, if we think in terms of the electric field, and we've got, so this is an end view, so the wave is coming straight towards us, is that the electric field is waving or oscillating in all directions. And this is what most electromagnetic waves would look like. So for example, electromagnetic waves, light waves from the sun, are unpolarized. Now, there are certain materials, right, so they have a certain crystalline structure that it only allows waves polarized in a particular direction to pass through. So you could think of it kind of like a picket fence. So imagine your electromagnetic wave, so imagine you have a rope and you're going to shake the rope to create a wave, and now the rope goes through a picket fence. Well, depending on, right, if the picket fence is straight up and down, well, if you shake the rope straight up and down, so if you're polarized up and down, then the wave will pass through. But if you try to shake it side to side, then the wave's not going to be able to pass through. And that's exactly how a polarizer works. It only allows waves polarized in a particular direction to pass through. So what happens then if you have an unpolarized, start with an unpolarized wave, you pass it through a polarizer, so actually then you'll get a polarized wave out. But since not all the energy is going to make it through, you only get half, you only get half the intensity of the wave comes through. And then what you can do is you can imagine different polarizers oriented at different angles with respect to each other. So you can actually use what's called Malus law to figure out what fraction of the intensity of the wave comes out. So this is the intensity coming out of the second polarizer is proportional to the initial intensity times cosine squared of phi, where phi is the relative angle between these picket fences, between these polarizers. And we'll do an example of this in class.